We're going to look at exponential functions, graphing exponential functions here in the first part of Unit 9, Section 1. We're going to look at number 1 right here. And actually, I want you to write some things down in your note packet here that I also have on your reference sheet. So the general form for an exponential function is y equals a times b to the power of x, and I like to put my b inside parentheses. Okay, this a will always be the y-intercept of the exponential function graph. And we talk about exponential growth and exponential decay. If b is bigger than 1, it's called exponential growth. The graph is going to be growing. If b is smaller than 1, and it will never be negative, so we're going to say it's between 0 and 1, it is exponential decay, which means the graph is going to fall. Okay, so let's go here and take a look at number 1. And we've got y equals 2 to the power of x. Now I'm going to do a little rewriting, and that is the same as y equals 1 times 2 to the power of x. So there's a 1 out in front here. That means that this is my a. My b is the thing that's raised to the x power. So again, with exponential functions, our x is up in an exponent. Thus, they're called exponential functions. So if you look at this, our b is 2 right here. That means that this is exponential growth. And we're going to make a table of values and see what happens here. Okay, so let's start at -3, and we'll go -3, -2, -1, 0, 1, 2, and 3. Okay, and actually I'm going to do one more here at 4. So if I plug them in, -3, I really have y equals 2. Y equals 2 to the -3rd power. Now remember, with negative exponents, that's the same as 1 over 2 to the 3rd. 2 to the 3rd is 8, so it's 1/8. So at -3, we're at 1/8. If I put -2 in, it would be 2 to the -2nd power, which is 1 over 2 squared, which is 1/4. So at -2, we're at 1/4. At -1, it's 1. Y equals 2 to the -1st, which is 1 over 2 to the 1st, which is 1/2. If I put in 0, it's y equals 2 to the 0, which is 1. So at 0, we're at 1, which is what the a value is, which is going to be our y-intercept. If I put in 1, it's y equals 2 to the 1st power, or 2. If I put in 2, it's y equals 2 squared, or 4. If I put in 3, I'm going to take 2 to the 3rd, which is 8. And then I'm going to do 2 to the 4th, which is 16. And this is where the exponential graph is going to shoot up really fast, exponential growth. So let's plot these points. So I've got -3, 1/8. So -3, 1/8. We're barely above the x-axis there. And then at -2, we're at 1/4. So we're just a little bit higher. We're at 1/4 right here. At -1, we're at 1/2. So at -1, we're about right there at 1/2. At 0, we're at 1. So about right there. At 1, we're at 2. So it's starting to increase. At 2, we're going to be at 4. So it's starting to increase faster. At 3, we're at 8, so it's starting to increase even faster. And at 4, we'd be way up here at 16. So what's going to happen is the x-axis here kind of acts like a horizontal asymptote. So this graph is going to be approach very close to it, but never touch it, and then it's going to shoot up really fast right there. And so this keeps getting closer and closer to that that x-axis, but never actually touch it. And that's exponential growth, because as we go from left to right, it's growing.